Yeah, so you should be able to relate the distance time graph and the velocity time graphs to the concept of integration, differentiation, and that way you will be able to figure out that, okay. Uh, Now, one thing is that we will be using the symbol X for distance, okay? So that's the symbol that we will be using for distance. Now, what's the relation? The relation is pretty simple. This concept is basically kinematics. And this is what you study in physics as well. I know some of you don't take physics. Yeah. So the idea is that if you have distance, then you can take the derivative of it with respect to time, because what is distance? Distance is how much length something has traveled. And when you take its derivative, you're basically telling how does that, the distance that it's moving, how does that change with respect to time? And that idea, that how is it changing, that is basically velocity, right? So that's what velocity is. And once you have that, you can use that to figure out that, okay, that is basically velocity. So dx over dt is velocity. Now, how does that relate? The graph can be of four different kinds for the distance time graph. You can have a graph that is like this. You can have a graph that is like this. You're going to have a graph that is like this. Or you can have a graph that is exactly at zero, like over here. Okay. So these four graphs. And how do they relate to this? I'll explain in a bit. Now, the next thing is how does velocity change? So dv over dt is basically acceleration. Again, the rate of change of velocity with respect to time is acceleration. So you have distance, you have velocity, you have acceleration. How does that relate? So it's going to be x, v, a. So let's suppose you are given a distance time graph and the graph is like this. Now, if they ask you to make velocity time graph for this, and by the way, this will help you in physics as well. This graph is going to be just like this, velocity time graph. And if they ask you to draw its acceleration time graph, it's going to be like this, acceleration time graph. Just like, remember this order. Whatever part they pick up, the other graph will tell you the distance, velocity, all of that. Okay, so this is your acceleration. Let's say in another example, they're like, no, actually, this one is distance. Let's suppose they give you a graph in which this is displacement. And displacement time graph, and they're asking you for velocity time graph. So velocity time graph for this one would be a straight line. And the acceleration time graph for this one would be this, 0. So while it's good to know how to graph it without making a mistake and to really remember it, what does it mean? It basically means how is this thing changing its distance? So if you notice, whatever is on the y-axis here, whatever is on the y-axis here, that thing is changing. Over here, the gradient is low. Over here, the gradient is higher. Over here, the gradient is even higher. Over here, the gradient is even higher. Basically, the gradient is increasing, right? And what's the gradient? That is dy by dx. So for this thing, the gradient is increasing. So if this is the gradient of that thing, this is how it will go. So this graph is basically of dy by dx. If that is y, this is dy by dx. And this graph is basically of the second derivative of that, or in other words, derivative of the derivative. And we know that distance, velocity, and acceleration are related through derivatives. So d by dt of distance is velocity, and d by dt of velocity is acceleration. What does that make the relation between acceleration and distance? It's the double derivative of distance or displacement, which is acceleration. Similarly, in the backward direction, we know that integration is antiderivative. So it is integral of this, and similarly over here, it is integral of this. Okay, so this we can use as our guiding principles to solve any question that involves kinematics or these kind of things. Okay, now just give me a minute. I'm looking for a question that involves this or that will allow us to make use of this process. Okay, so here we have a question. So there's a particle traveling in a straight line, passes a fixed point O on the line with a speed 0.5 meter per second. So at O, velocity is 0.5 meter per second. The acceleration is A, which is 1.4 minus 0.60. Okay. Show that the particle comes instantaneously to rest when t is 5. So instantaneous to rest means that the velocity is 0. Now we do not have an equation for velocity. So how do we figure that out? We know the relation between displacement, velocity, and acceleration. Acceleration is derivative of velocity, which means velocity is integral of acceleration. So that means if I want to find velocity, I'll simply integrate acceleration. And I know what acceleration is. It is 1.4 minus 0.6 t, and I'm integrating it with respect to t. Remember this, it is important to know what variable you are integrating it with. So we are integrating it with this one. So this one would become 1.4. Right now t has a power of 0, so it becomes t power 1 divided by that power. Okay, and then minus 0.6 times t, and t has a power 1 right now. You increase the power, it becomes 2 divided by 2, and obviously plus c or plus k or whatever you want. So it becomes 1.4 t minus 0.3 t squared plus c is velocity. Okay, and we know that the starting value when t is 0, this thing has a speed of 0.5. So at t is equal to 0, the speed is velocity is 0.5. So we plug that in. 0.5 is equal to 1.4 times 0 minus 0.3 times 0 squared plus c, because I know the time is 0. So this whole thing goes to 0, this whole thing goes to 0. So c is equal to 0.5, which gives me the full equation for velocity, which is v equals 1.4 times t minus 0.3 t squared plus 0.5. So I've found the velocity, and that's exactly what I had to find out. Now at t is equal to 5, what does that become? Let's see. So at t is equal to 5, we plug in here. Okay, so 5 squared plus 0.5. All right, so does anybody have a calculator? So this thing would become 7. This is 0.75 and this is 0.5. Sorry, 7.5. So you get 0 here. So v at t is equal to 5 is 0. So that tells me that it does actually come to rest when time is equal to 5. All right, next part. Find the total distance traveled by the particle between t is equal to 0 and t is equal to 10. Now I want to find distance, and distance, I know the relation between velocity and distance. Velocity is derivative of distance, so distance is integral of velocity. Okay, so we do that, we integrate velocity. So integral of velocity with respect to time will give me displacement. Okay, and that will give me, I'll integrate this again, same principle. This is algebraic function, so it's pretty easy to integrate. You just have to remember how you're going to do that. You add 1 to the power divided by the power, and and the derivative of whatever's inside. Now there's another information in the question here. They're saying between t is equal to 0 and t is equal to 10. So that means your limits are from 0 to 10. Okay, so this time we are actually using definite integral where we have the displacement and all that. Okay, so we do this, it gives me 1.4 t squared divided by 2. Why? Because right now power is 1, add 1 to it, divided by that. Similarly, this is power 2, add 1 to it, divided by that. And right now the power is 0, so add 1 to it, divided by that. And we don't have to put plus c or plus k or anything because we have the limit. So this is 0 to 10. So we just apply that. First simplify it, always simplify things first. So it gives me 0.7 t squared minus 0.1 t cube plus 0.5 t, 0 to 10. So you can simply apply this. Now, another useful trick that we can learn is that we have t in each one of them, right? So that means if I put 0 in there, everything is going to be 0. So I don't actually need to go through that. I'll simply do this. 10 squared minus 0.1, 10 cube plus 0.5, 10. Now I can write the lower limit 0 here, but because I know that it's all going to become 0, I can just skip on that. Okay, if you want, you can still write this, and that way you will get that this is 70, this is what, 100 I guess, and this is 50, so whatever you get, plus 20 I guess. So that is the total displacement traveled by the thing in that. Now remember, this is the total displacement, but what was the question asking us of? The question was actually asking us for total distance. All right, so that means there is something wrong here. What's happening basically is that, do you notice that thing was traveling from 0 to 10, and in the middle at t is equal to 5 it actually stopped, right? It had a value 0 for velocity. Now that means 20 might be the displacement, but 20 is certainly not the distance. For that, we'll basically have to break it down. From 0 to 5, it was probably traveling in one direction. Okay, so maybe it was going like this from 0 to 5. At 5, it turned and started going in the other direction till t is equal to 10. So there are two parts of this journey. First is from 0 to 5, and second is from 5 to 10. So we should actually try to do it for 0 to 5 first and 5 to 10 after that. And let's see if that makes a difference. So the distance value was given by 0.7 t squared minus 0.1 t cubed plus 0.5 t. Let's see, 0 to 5. And then we do the same thing from 5 to 10. Okay. Now let's see, does it really cancel out this time? So when you apply the limits, I'm going to use a calculator for this. So this part of the journey comes out to be 19.8. Now let's see how it goes for the second part. That is minus 11.5. Now remember that this is minus 11.5 in the opposite direction. So we will have to basically flip the sign. So it becomes minus of that. So that gives me 19.5 plus 11.5. Basically, the thing has traveled 31 meters or centimeters or whatever you have. That's the distance that it has traveled. But because the direction was changing, it flipped. Does that make sense?
Yes, sir.
Any questions?
Sir, एक और question करना.
Of course.
Because I'm still a bit, like, it's a bit confusing. Like the
No
last
problem.
part especially.
Of course, of course. We'll do that. No problem. This one is a really old question. I don't have the most recent book right now. Okay. A particle moves so that t seconds after passing through a fixed point, its velocity is given by this. So v is ae minus kt. We don't have a, we don't have k. All right. When t is 0, velocity is 5, and when t is 10, velocity is 3. Okay, so we have some leeway. So let's apply this. When t is 0, it becomes a e power minus k times 0. And when t is 10, this becomes 3 equals a e power minus k times 10. All right, from over here, we can see that this becomes a e power 0, which means it becomes 5 is equal to a, because e power 0 is 1. You can plug that in there, and you'll get that 3 is equal to 5 e power minus 10k. I get 3 by 5 here. This is e power minus k times 10, sorry. Now, if I want to find k, or to make it the subject, I'll take ln on both sides. Why ln? Because I have to get rid of e. Again, you can take any other log, won't make a difference. The answer will still be the same. So you'll get minus 10k equals to ln 3 by 5. This will be a negative value, so you divide it by 10. So ln 3 by 5 divided by negative 10, that's your k. Put it in a calculator and you'll get it. So ln 0.6 divided by minus 10, that tells me k equals 0.0511 to 3 significant figures. And it's important that you write your answers to 3 significant figures. Okay, let's move on. Second part says the acceleration of the particle when t is 10. Now this one's easy because we have the velocity. Now the relation between distance, velocity, and acceleration is of derivatives. So velocity's derivative is acceleration. So if I want to find acceleration, I will have to find dv by dt, which is what? d by dt of the function. The function is 5 e power minus 0.0511 t, because I plugged in the values from last part. If somebody got the last part wrong and they just put some values in there, that's perfectly fine. They can just take the values that they had in the last part. So we know we want it for 10, t is equal to 10, but we can't apply it directly. We first have to find rate of change. Now that will become 5 e power minus 0.0511 t. And we know that derivative is basically dividing it by this power. So this power's derivative is this, we divide by that. At t is equal to 10, so now we can apply the values. So at t is equal to 10, this thing becomes, acceleration becomes 5 e power minus 0.0511 times 10 divided by minus 0.0511. And you can just plug that in a calculator to get your final answer. Okay, so pretty simple. Let's do another question. This one's a relatively conceptual question. We have the velocity. Now this is more like a description question. It won't be on the test, but or the exam, but it helps clarify our concepts. So it's saying a particle moves in a straight line with velocity this. Draw a sign for velocity. Okay. Sign diagram, have to figure out where it is negative, where it is positive, how is it moving. So I know you just have to graph it. Now you can graph t squared minus 6t plus 8. So you'll notice that what are the roots for this thing? Let me just factorize this. So this becomes t squared minus 2 times t minus 4 times t plus 8. That gives me t minus 2 and t minus 4. So that means my graph is basically going like this. So t is equal to 2, t is equal to 4. The graph is going like this. Right? Now you can see that my graph is below the x-axis over here. As long as x is between 2 and 4, my graph is negative because my value of y is negative. It is below the x-axis. On the left side is positive, on the right side it's positive. So we can say that the signs for the graph would be basically be, it'll be give us a positive value here, negative value in the middle, and positive value here, right? So this is tantamount to solving the inequalities that we did in the first part of the syllabus, where they ask us where is y greater than equal to 0, or where is y less than equal to 0. So this is just like that. Okay, B part. describe what happens to the particle in the first 5 seconds. So how's it going? At t is equal to 0, it has some value. It keeps going down, its velocity keeps going down until t is equal to 2. So that's where the velocity is 0. Now remember one thing, what does it mean for something to have velocity 0? It means that thing is either stationary, obviously it is stationary, but it can also mean something else. It can also mean that that is the point where that thing is changing direction. So velocity 0 can mean two things. One, of course, that thing is stationary, but that could mean that either it's not moving at all, or it is moving, but it's changing direction. Okay? And whenever things change direction, you make sure that you integrate them separately. So if I wanted to find the area of this graph, I will do it for 0 to 2 first, then I'll do it for 2 to 4, and then I'll do it for 4 and above. I'll actually break this function down into 3 parts because there are 3 parts to this graph. Okay? So remember this thing. Whenever velocity is 0, the thing might be stationary or it can be changing direction. And if it is changing directions, then you integrate that area separately. All right, so coming back to the question, describe what happens to the particle in the first 5 seconds. So it's moving from a constant velocity. It started at some velocity. That velocity decreased to 0, reached 0 at x times equal to 2, then went increasing in the opposite direction. Okay, it increased in the opposite direction until t is equal to 4, where it became 0 again, and then it starts flying. So we can say that this thing was slowing down like this, started speeding up in this direction, then slowed down again, or started increasing again. So when it was at t is equal to 0, it was here. At t is equal to 2, it was here. At t is equal to 4, it was here, and then it started going. So this is how this thing is changing its velocity. Okay. After 5 seconds, how far is the particle? Okay, so we want to find distance. Again, if you want to find distance, which is x, then that is going to be integration of velocity. So if I want to find the integration from 0 to 5, I want to find the total distance traveled from 0 to 5, I will have to make sure that I do it in 3 steps. So there's the 0 to 2 part, and then minus of the 2 to 4 part. Why negative? Because it's changing direction. So that part, and then plus because it's again in the positive direction from 4 to 5. It is very important for you to know how the graph is changing direction or where the thing is changing direction. And how do you know there's changing direction? Just find out where the velocity becomes 0. If the velocity becomes 0 and the thing is moving, that means it's changing direction. And that's where you break your integral up into multiple parts. So I'll just find the integration of this thing. So integration is easy. I just have to integrate it once. So t squared minus 2t minus 4. Sorry, where was it? Minus 6t minus plus 8. That's what we have to integrate. So it becomes 3 cube over 3 minus 6t square over 2 plus 8 times t. That's the integral, right? I'm not adding plus k or plus c because I have to apply limits. So from 0 to 2, what is it doing? From 0 to 2, it's going from 2 cube over 3 minus 6 minus 0 and all that. So 0 cube over 3 minus 6 into 0 square over 2 plus 8 times 0. That is the distance traveled from 0 to 2, this part. This is the distance traveled here. Now I want to figure out the distance traveled when it was in the opposite direction. So this thing again, plus 8 times t, 2 to 4. It will obviously help if you were to simplify this before you applied the limits. So now it's going to be
Sir, आप further simplify कर लेते ना 3 को 3 से. Oh,
3 को
actually
3
नहीं
से नहीं
होता
कर
ना.
सकते. There is a
Sorry,
minus
वो
sign
minus
there.
sign है. Yeah, I just saw.
Yeah. Okay, so you do that, you will get some values. So you're getting 12. Now this is your answer from 2 to 4, and then uh, we have to do the same thing, but the limits are going to be 4 to 5. So do it for 4 to 5. You get 5.75. So your total distance is going to be the first one, which was from 0 to 2. Let me apply the limits for that. So that was 28 over 3. So this was 28 over 3. 28 over 3 plus 23 over 4 plus 12. This one, and this one. And that is how you get your final answer of what this thing, the distance traveled by this thing. Okay, so just give it in a fraction. You don't have to approximate it. That's the total distance traveled. Okay, this sign, negative sign, we won't need it because the distance still came out to be positive. So we didn't really need it. Okay, does that make sense? How we found distance from velocity? And is it clear why we
Exactly.
had to change signs and why we had to break the limits? Why couldn't we just be like, okay, from 0 to 5? We couldn't do that because the thing was changing direction. Every time the thing changes direction, the limits have to be changed and we have to break the integral. Okay. Find the total distance traveled. Now the C part was basically about this, 0 to 5 v dt. And the D part is about this. So can anybody tell me what the main difference is in these two integrals? Of course, here we are also integrating from 0 to 5, and here we are also integrating from 0 to 5. What's the difference?
Sir, because in the second one, we had to weren't we changing directions?
Yeah, we were considering the change of direction.
Yeah. So in
But in the first one, we
one,
are not considering that.
yeah, we were just
So in
going in
physical
one
terms, what does
direction.
that mean? In physical terms, what does that mean?
Sir, I don't get the word physical terms.
Like in the real world, what would it imply? So this implies, this one implies displacement. Okay, like how far the thing is. So it started here. Let's suppose at t is equal to 5, it's over here. So the displacement, the overall distance traveled is this. How far is it from the 0 point? But this one is telling me distance.
Distance.
Okay, so there's a difference. If they ask us how far is the thing from its original position, as they have done in part C, they're basically asking us for displacement. When you're trying to figure out displacement, you don't care about changing directions or when it was 0 and all. You just integrate the whole thing and that will give you the displacement. Okay, because what it
Yes.
does is, if you have traveled, let's suppose 5 steps in the right direction and 3 steps in the backward direction, you're basically 2 steps away from the starting point, right? So this was your starting point. You went 5 steps here, 3 steps back. So how far are you from the starting point? Just 2 steps. But how much distance have you traveled? How many total steps have you traveled? You have traveled 8 steps. So saying that you traveled 8 steps, that is distance. And saying that you basically traveled 2 steps, or you're 2 steps away from your starting position, that is displacement.
Okay, sir.
Yeah. So that's what this whole concept is. Okay.
Usually कितने marks का question आता है इस topic पे?
4 to 6 marks.
Answer कितने questions आते हैं? Like एक से
एक
ज़्यादा
क्वेश्चन
आता
आता
है?
है, एक ही क्वेश्चन आता है इसके ऊपर.
Okay. Because sir, this is
Yeah.
really lengthy. बहुत lengthy. Even though
Yeah.
it's understandable, but it's really, really lengthy. And I have a
I agree.
strong feeling that kids get confused. I would for a fact get confused के बीच में मैं जब एक की integration करूँगी फिर दूसरे करूँगी I know के values में mix up कर दूँगी या कुछ होगा I know for a fact.
No,
It's just
that we can change that fact. Whenever you have something like this, practice, be familiar with these questions and be mindful of the mistakes that you make.
Yeah, so like अभी I made a very general mistake कि मैं उसको एक 3 को दूसरे 3 से मतलब cut करने वाली थी when I was
Yeah.
like solving with you.
Yeah, I saw
See,
that.
I do make mistakes like that, especially
But
in
you see,
such
you
like
were the one who said, okay, we can't do that. You were the one who identified it. So just
Yeah,
having some patience
but
helps.
पर like सिर्फ patience का time नहीं है ना CIE सर पर है.
More time hai. Have confidence, have faith in yourself. You
See,
have
I have
time.
no faith in myself and no one
Okay,
around
this
me
is
has
recording.
faith
I
in
should
me.
stop the recording then.